In this lecture, we will prove the statement which says that every spanning set contains a basis. What does it mean? By the statement is we have a vector space Bf and we have some vectors v1 to vn which spans whole vector space. Meaning of spanning has been discussed in previous lectures. You can visit if you do not know what does mean by spanning. So if this set spans whole vector space, it means it contains a basis, means subset of this set will be Li also and spanning also. Okay, so we have to prove these things. Okay, so at first we will assume we have a spanning set and we will find some of the vectors which will also Li and spanning, and that set will be the basis of the vector space. So let V have a vector space. Let V over F be a vector space. Okay, we have a vector space, and also let v1 v2 dot vn is the this is the with the spanning set. Okay, a spanning set, it means it span whole vector space. Now we will find a subset which is spanning also and Li also, means that will be the basis of the vector space. So we will do it in the step by step we will do. So the step first, if v1 is 0, okay, we are trying to make a subset. It means we have a empty set at first. In initial we have a empty set, and if v1 is 0 vector, okay, if it is v1 is 0 vector, we do not take in my empty set. Else if it is non-zero vector, we will take in my empty set, and new set will be the set with element v1. Okay, step second, if v2 is LC of v1, what does it mean? Well, if v2 is alpha into v1, LC means we have only LC of v1 means linear combination of v1, and since we have only one vector, so it will be alpha into v1. If this is equal, we do not take in my set. Else what we will do, we will take in my set, and it means we have a new subset v1 comma v2. Okay, so what we are doing here, we are taking the vectors which are not the linear combination of previous all these vectors. Okay, so in a step j, vj, if vj is not linear combination of v1 v2 dot vj minus 1, vj minus 1 means what? If this is not linear combination of all these vectors which are previous to vj, we will take vj in my set. Okay, so new set will be this one. Okay, so we are taking only those vectors which are not the linear combination of previous one. What does it mean? We are taking only linearly independent vectors. Okay, so this is by constructor linearly independent. So now, so assume it stops it stop at m step. What does it mean? Means we have a set. What we are constructing is b1 b2 dot dot vm, and by constructions this is li. Okay, and if this is a spanning, then we can say that this is a basis, and all those vectors are taken from v1 v2 dot dot vn. So obviously here m will be less than equal to n, either it will be equal to or it will be less than. Okay, now if it is a spanning vector, we are done. So let v belongs to v over f. We have a vector from the vector space v. So since v1 v2 vn a spanning set, it is the spanning set, so it can span this vector. So we can write c1 v1 plus dot dot cn vn. Now we have got the new set of vectors. Okay, and how we got? We have removed only those vectors which is linear combination of these vectors. So we have removed, we can write here the vectors, if the vectors which are removed is used here, that vector can be written in the linear combination of v1 v2 vm. Okay, I am repeating what I mean to say is that if the removed vector is used for the spanning for vector v, and v is arbitrary vector, the removed vector, if v we can say here any vector vi has been used and it is removed from the this set v1 v2 vn and got the new set, that means vj is not in this set. So vj is linear combination of v1 lc of v1 v2 dot dot vm, because we are constructing in that manner. It means that we can write v as the linear combination of v1 v2 vm, because we can replace vi as c1 v1 plus dot dot cm vm. Whatever vector has been removed, that vector can be written as a linear combination of v1 into vm. So we will only use the vectors v1 v2 vm for constructing the vector v. It means what? It means it can be written as alpha 1 v1 plus alpha 2 v2 plus dot dot alpha m vm. This will imply set v1 v2 dot dot vm is a spanning set also. So it is li by constructions, and it is a spanning set, will imply v1 v2 dot dot vm. This is subset of v1 v2 dot dot vn is a basis. Okay, so new set is a basis, and say every spanning set contains a basis.